Hello, today we're going to have a look at rationalizing denominators. So to start off with, let's have a look at an exam question. We're looking at OCR Core 1, June 2008. Express each of the following in the form k root 2, where k is an integer. So we're looking to write the square root of 200 as something times the square root of 2. Well, using what we did in the previous video, I'm going to write this as the square root of 100 multiplied by the square root of 2, and then I know how to square root 100, that is just 10, but I can't square root 2, so I need to leave that as 10 root 2. And I've got it in the form an integer, my k value being 10 times root 2. Now on this one, it's a little bit harder because I've got the square root on the bottom, and this is what we call rationalizing the denominator. I want to remove the square root from the bottom of my fraction. To do that, I'm going to multiply top and bottom of my fraction by whatever's on the bottom of it. So I've got the square root of 2 on the bottom, I'm going to times it by the square root of 2 over the square root of 2. You'll notice the square root of 2 over the square root of 2 is actually just 1. So I'm multiplying by 1, I'm not changing what my answer is going to be. 12 times the square root of 2 is 12 root 2, and then the square root of 2 times the square root of 2 is just 2, because it's the square root of 2 squared. And now I can simplify this. I can divide numerator and denominator by 2, and I will just get 6 root 2. So 6 is my integer. And then the last one isn't a rationalizing the denominator one. We're just going to simplify both of them into lots of root 2. So I can say that 5 root 8 is equal to 5 times, well, root 8 is root 4 multiplied by root 2, and I can simplify this down to 5 times 2 times root 2, or just 10 root 2. So the question's really saying 10 root 2, take away 3 root 2. Well, 10 lots of something, take away 3 lots of something, just leaves me with 7 lots of it. So the new bit here is the rationalizing the denominator, and if we've only got one surd on the denominator, I just multiply top and bottom by that surd. Unfortunately, it's not always that straightforward. Let's have a look at another exam question. So the first bit, 3ai, says express root 18 in the form k root 2. We should be experts at this by now. I'm going to write root 18 as the square root of 9 multiplied by the square root of 2, and I can square root 9 to get 3 root 2. Now this one looks like I need to get the square roots off the denominator. But before I start doing that, I would recommend simplifying your square roots as much as possible and trying to make it into nice numbers, because the square root of 32 is horrible. So I'm going to start off with my root 8 over my root 18 plus my root 32. And I'm going to say, how can I simplify that? Well, root 8 is root 4 multiplied by root 2. And on my denominator, I get root 18, which is the square root of 9 times the square root of 2, plus the square root of 32, which is 16 square rooted times the square root of 2. And now I can square root these square numbers, so I get 2 root 2 over 3 root 2 plus 4 root 2. So I get 2 root 2 over 7 root 2, because 3 lots of something plus 4 lots of something is 7 lots of it. Now I can cancel my root 2's, and I'm just left with 2 sevenths. So I didn't need to do the rationalizing the denominator because the square roots just cancelled nicely for me. That will not always be the case. And if you have a look at part B, we can have a look at an example where my square roots don't just cancel. So there are no square roots to simplify here. I get the 7 root 2 minus root 3 over 2 root 2 minus root 3. Now this is different to the one we had before, where I just had one square root on my denominator. This time I have 2 square roots on my denominator. It doesn't matter if it was a number minus root 3 or whether it's a surd. It doesn't make any difference to what we're going to do. We're going to change the sign in the middle. So because there's a minus here, I'm going to multiply by 2 root 2 plus root 3 over 2 root 2 plus root 3. So just like before, where I said this red bit was equal to 1, this is still equal to 1. But it's a little bit more complicated and I need to be slightly more careful when I'm expanding it. So what I'm going to do is I'm going to treat it as if I was expanding out brackets. I'm going to do 7 root 2 times 2 root 2. Well, 7 times 2 is 14. And then my root 2 times my root 2 gives me plus 2. So this is 14 times 2. And then I get 7 root 2 times root 3. Well, we said before, if I had root 2 times root 3, because it's a times, I can combine them into one square root. So I can say that this is the square root of 6. So I can say that this is actually plus 7 root 6. And then I do the same for my minus root 3. Minus root 3 times 2 root 2 gives me minus 2 root 6. Minus root 3 times plus root 3. Well, my root 3 times my root 3 becomes 3. But my plus and a minus makes it a minus. I have that all over. I'm going to do the same on my denominator. I'm going to do 2 root 2 times 2 root 2 gives me 2 times 2 is 4. Root 2 times root 2 is just 2. And then 2 root 2 times root 3 is plus 2 root 6. And then when I multiply out this one, I'm going to get minus root 3 times 2 root 2. Well, that's going to give me minus 2 root 6. And minus root 3 times plus root 3 is minus 3. You will notice that my minus 2 root 6 and my plus 2 root 6 cancel. The reason that is it's like the difference of two squares. So my middle terms are going to cancel. That's why we change the sign. So the bit at the start becomes squared, so that gets rid of the square root. The bit at the end becomes squared, so that gets rid of the square root. The only square roots that are left are in the middle bits, but because we changed the sign, they're going to cancel. So I can simplify this. I can say 14 times 2 is 28. 7 root 6, take away 2 root 6 is 5 root 6. Minus 3, and on my denominator I get 4 times 2 is 8, minus 3, and my 2 root 6 and my minus 2 root 6 cancel. So I get 25 5 root 6 over 5, and then because everything on the numerator and the denominator is times by 5, I can cancel my 5's, and that will leave me with 5 minus root 6. And if we have a look back, that is in the form m plus root n, where m and n are both integers. So to recap, if you had a over root b, I would rationalize the denominator of that by saying it's a over root b times root b over root b. But if you had a plus or a minus on the denominator, so if you had, say, 6 minus root c, I would multiply top and bottom of that by change the sign. It doesn't matter whether the square root's at the start or the end or in both bits, you're going to change the sign in the middle. And it will give you something like the difference of two squares where your middle terms will cancel.